guys, welcome to my YouTube channel, the IT Man. Today we are going to discuss the problem of the day on Leetcode. So it is binary search tree to greater sum tree. So like the problem given is we have given a binary search tree and we have to convert it to a greater sum tree. So like as we all know the properties of the binary search tree, that is the left one will be smaller than the node key and the right one will be will be greater than the nodes key. Okay, the right nodes with the keys. Okay, so like keeping in mind those properties of the binary search tree, so we will try to find out the solution. Okay, so let me just go to this tree. So like what is the requirement here is like we have given the binary search tree. Okay, so like we have to convert it to a greater sum tree. Okay, that is GST. It is greater sum tree. Okay, so like let's suppose this tree is given the root node value is 4. If we go to the right 7, then 7, then so we will first try note up the values. Okay, like what will be the number greater than 8. So there is no number is greater than 8. Okay, so we will write the solution here like for the 8 node. So okay, so here the answer will be 8. Okay, answer will be 8. Then we have 7. Okay, because it's a binary search tree, it follows the property. Okay, the most right one will be the greater, right? So we will start from the most right one. Okay, because no one is greater than 8. Okay, so in binary search tree the element in the most right of a tree, okay, will be the greater. Okay, so we will start from the right end only. Okay, then we will go to the 7, then 8 plus 7 15. Okay, then we will go to 6, 15 plus 6 21. Then we will go to 5, 21 plus 5, that is 26. Then we go to 4. Okay, so 26 plus 4, that is 30. 30, and then we will go to the rightmost. Okay, rightmost of a subtree. Okay, then we will go to the 3. So answer will be 33. Okay, then we will go to the this node which is value 2. Then 33 plus 2, it is 35. Then we will go to 1, and 35 plus 1 is 36. Then we will go to the left. 36 plus 0 is 36. So like this tree is converted as a greater sum tree. Okay, so we simply have to add the maximum values. Okay, like let's take an example of 8. Okay, like what is greater than 8? Nothing, so we will have to put 8. Then we will go to 7. What is greater than 7? That is 8. So 8 plus 7 15. Then we will go to 6. So we will check what is greater than 6. So these some 6 plus 7 13 plus 8, that is 21. So we will have to add the more greater element, okay, of that particular node key. Okay, like what is the elements greater than or equal to 6 will be getting added here. Okay, the most greater elements than the 6. Okay, so these keeps on adding, and then we will simply replacing these values with the greater sum values what we have achieved. Okay, so this is how it is going to work. Okay, so let's try to implement the solution here, like how it will work. Okay, so simply it's a binary search tree. So one thing is clear, like we have to traverse this tree. Okay, so like we have while we were trying to find the solution, so like we have seen like we have started from 8. Okay, that is the most right element of the array. Okay, so like this function also involve recursion here. Okay, so we will to start with 8. Let's suppose this is our function in which root node is given. Okay, so how we can find a solution here, like we will check if we will check here if root dot right, okay, that is not equal to null. Okay, till then we will be keep traversing to the right. Like I hope you have already know about three types of traversal of a tree. Okay, that is pre-traversal, in order traversal, and the post traversal. So here we are implementing the what we are implementing, right, uh, right, then we will traverse root, then we will traverse left. So here what we will do, root GST, we will keep calling this function, okay, root dot root dot right, okay, we will keep calling this function, okay. And on every traversal we have to add the values, okay, value equal to value plus, because when it achieves 8, okay, we have to add that 8 here, okay, value plus what we get, the root dot whatever value root will have, we will keep adding it, okay, so that uh, we can have the proper sum, okay, at every node, okay. So like we have to replace this node value also by the sum, okay, by the sum we are getting. So what we will do here, we will say like root dot value, so it will also keep replacing, okay, because these values we are not needing anymore, okay. So at the same time we have to create a greater sum tree, so at the same time we will keep replacing the values, okay. Then what we have to do, we suppose let's suppose it comes to 8, okay, then uh, it will go back, okay, the backtracking will work here, it will go to 7, then 15 comes, it will go to 6, so it has reached the root node of the subtree, okay. Then we have to traverse the left one also, now we have to go to the left, okay. So for this one we will add one more condition here, if root dot left, okay, not equals to null, okay. So what it will do, we will call this function gst root dot left, okay, and then what we will do, we will return the node, we will return node, okay. So this is the simple solution for this, so let me try to implement it. So along with that I will try to explain this, okay. So let's go to the problem, okay. So what we will do here, we will create a global variable, okay, sum, that will contains the values, okay, the total sum at each node, okay. So okay, so like first we have to go to that this element 8, okay, we have to go to the rightmost element. So if root, sorry, root root right not equals to null, what we have to do, we have to keep traversing it. I'll just copy and paste it, root dot we have to keep traversing to the right, okay. Then what we do, when it will reach to the most right element, we have to maintain the uh, we have to add the value of it, okay, whatever that node contains this value, so we have to add it, okay. So root dot value, like how I'm getting that root as value or not, because like this tree node is initialized like this, okay. So value is called as val here, left and right too, okay. Like these are pointing to the left node, this is pointing to the right node, and this is the node value, okay. Then I will check. So like we have the now sum here, okay. So along with the sum we have to keep replacing the values to make it as a greater sum tree, okay. So at the same time I will do root dot right equal to sum, sorry, not right, root dot val equal to sum, okay. So like this is done, so like 8 is done, then it will goes to 7, and when it will go to 7, so what will happen, again it will keep adding 7, and then it will go to 6. So now it is gone, it is traversed the whole right side of it, of the node, okay. Now the left side will also come. So to make it root dot left, we will check whether not equals to null, and we have to traverse the left subtree also, okay, root dot left, okay. And at the end what we have to return, that is root, okay, root node, so that will be pointing to the 4 only. So this is how this solution will work. Okay, so let me tell you what we have done till now. Like, we will first need to go to the rightmost element of the tree, because it's a binary search tree. The maximum element will be the at the rightmost end. Okay, so we will keep traversing until we will get the rightmost element. So we have added a condition until root dot right node equals to null. Okay, so it will comes to 8. Then what we have to do when it comes to 8, we will simply add it sum equals to sum plus root dot value. Okay, we will get the sum, that is 8. We will replace that root value, and then so similarly when it goes to 6, we have to track this left subtree also, right? So we will go to the left similarly. Okay, so and then at the end we will return the root, because these values we have already replacing with the greater sum. Okay, so this is how this tree will work. Let me try to run it. Yeah, so it is accepted. We will submit it. Okay, so it is working fine. So guys, do let me know if there is any issues while implementing this solution, or if you face any issues, do let me know in the comments. So please like, share, subscribe. Thank you so much.